All right, hello everyone. Wanted to cover the bug problem here. Classic question that typically students struggle with on day one. So let's read the problem. A bug is moving along the right side of the parabola y equals x squared at a rate such that its distance from the origin is increasing at 1 centimeter per minute. I just realized I want to call this green length, which is his distance from the origin. I'm going to call that capital D. You'll see why here in just a second. So I'm given, based on that information, that dd dt is going to equal 1 cm per minute. All right, so that's one of those given values. At what rate are the x and y coordinates of the bug increasing when the bug is at the 0.24? So I've got my when. Here's my when. My when is the 0.24, right, which is right at this point. All right, so you can see that this triangle that I've sketched here with legs of length x in red and y in blue and a hypotenuse of d in green would relate in the following way: x squared plus y squared would equal d squared using Pythagorean theorem. So if I were to take the derivative of that right now, that would be, somewhat complex, just due to the fact that I've got three variables present. So what I'm going to do is I'm going to actually do a substitution, and I'm going to call y x squared. So watch what I do here. I'm going to do x squared plus x squared squared. And why would I do that? Well, for a couple of reasons. How can I do that? It's because of the relationship here between x and y. And why would I do that? Well, I'll show you here in just a moment. So I'm going to rewrite this as x squared plus x to the fourth is equal to d squared. And now I'm going to differentiate both sides with respect to t, ddt, ddt. All right, so if I differentiate this, I would get 2x times dx dt plus 4x cubed times dx dt. So if I wouldn't have substituted in x squared for y, I would have a dx dt and a dy dt, which would be a problem. All right, and then this all would equal 2 times d times dt. Okay, so let's identify a few values here. I was given that x equals 2, so I'm going to plug in a 2 everywhere I see an x. And I'm going to leave my dx dt there because that's typically, well, that's not typically, that is what I'm trying to find. But I don't know d, or do I? So I got to do a little work here to find that length d. Well, using Pythagorean theorem, I can clearly see that if I had legs of 2 and 4, this would end up being the square root of 20, which I could write as 2 root 5. All right, so d would equal 2 root 5, and dt I was given right here is 1. Okay, so I can find dx dt. All right, so that doesn't solve for me, though, what dy dt is. So let's figure this out, and then we'll figure out dy dt. So this would be 4 dx dt, which is the change of the bug in the x direction, right? Plus, what would that be, 32 dx dt, right? 8 times 4 is, yep, 32. This would be 4 root 5. Okay, so that means I've got 36 dx dt is equal to 4 root 5. Okay, so I'm just going to do some division here and find that dx dt would equal square root of 5 over 9. And that would be centimeters per minute. So that's the rate of change of the x value when the bug is at the point 2,4. Now notice the slope on the curve, right? Y equals x squared. It looks like the y is going to be changing at a rate much larger than the x value. Right? You can see that dy dx there is probably greater than 1. Therefore, the change in y, dy, would be greater than the change in x dx. So let's figure out how we would find dx dt, or dy dt, excuse me. So if y equals x squared, I could find dy dt by differentiating both sides. Oops, that, again, I didn't plan ahead there, did I? Okay, I would have dy dt is equal to 2 times x times dx dt. So dy dt at x equals 2 would equal 2 times 2 times dx dt. And dx dt at x equals 2, check it out right here, ends up being square root of 5 over 9. Thus, dx dt at the point 2,4, we already knew that was square root of 5 over 9 centimeters per minute. And dy dt at the point 2,4 ends up being 4 root 5 over 9. Pretty cool. That's the bug problem. Hope it made some kind of sense. Related rates. Go get them.